Okay, so like what was saying, we already evaluated our integral over momentum, and all you get is a root 2m pi kt all cubed, right? Now that is pretty straightforward. Like I said, we already did that. That's for an ideal gas. So then your partition function eventually becomes, we have z is equal to 1 over n factorial 1 over h cubed. Then we have this, which is times root 2m pi kt cubed. We'll make this to the 3n. Also, this goes to the 3n. And then we have this integral of the d3r1 d3r n, and then we have this potential e to the minus b u potential, right? So this, we also should look kind of familiar. We did it back, I think in chapter 6, I believe, and it ends up, we just get the z, the partition function for the ideal gas. The only thing we're missing here is a factor of 1 over v to the 3n, I believe. So then we just get times 1 over v to the 3n, or is it to the n? Excuse me, that should be just to the n, yeah, because it was just the cube. And then that is also times this whole thing, which is just integral d3r1 d3r n. And then we have this again, this potential. So basically the only thing that we don't really have yet is this right here, and we'll just call that ZC. We can just kind of drop this whole thing out here, and we're just going to focus our attention here because this is what we had to work with. This is kind of we've already done this, so we'll just focus our attention there.